Good morning and welcome to this morning's webinar presented by ActiveState and by Piston Cloud. My name is John Wetherill. I'm Technology Evangelist at ActiveState. I've been here for almost 3 years now, focusing heavily on platform as a service, containerization, microservices, and a number of other cloud development related issues, and that's after my long career as a software developer. And I'm very pleased this morning to be joined by Shawn Madden from Piston. And Shawn, would you like to introduce yourself?
Yeah, sure. Hi, this is Shawn Madden from Piston. I'm a product manager. Been here about 2.5 years, working on what originally we started doing OpenStack, and then lately we moved into, and just announced a couple weeks ago, the new Piston CloudOS. And we're going to be focusing on a lot of multiple frameworks that are going to be running on top of this CloudOS, and we'll talk about that a little bit during this webinar, and as well as the Piston and ActiveState integration of running Stackato on top of Piston CloudOS.
Very good. Well, Shawn, it's great having you, and I do regret that I wasn't able to make it to your office today. It's you guys are in San Francisco, I'm in Santa Cruz, and it's at this time of day, it would be about a 2.5-hour drive for me to get there, and I just wasn't able to pull it off. Next time we'll do it in person.
Yeah, so, most definitely.
As I mentioned earlier, I'm with ActiveState. Just a brief introduction of the company. We're based in Vancouver, beautiful Vancouver, Canada. I'm remote. I'm working in Santa Cruz, California, as I said, but we're based in Canada. We've been around for quite a while, about, I believe, 17 years now. And we originally started building language packs and development tools, but language packs for like Perl and Python and Tickle and a few other packs for language support on various platforms. And we also built an IDE called Komodo, a very powerful IDE for dynamic languages. It's quite popular. Recently, we have dived into the platform as a service space for a little over 3 years now. We offer a Cloud Foundry-based PaaS. So it's based on Cloud Foundry. It's enterprise hardened. It has a number of features that make it very suitable for running enterprise applications in production. So, high availability and security features, and scalability and performance and usability features. So my role here is focusing hard on the PaaS, platform as a service. And today's webinar will be focusing a good chunk of it on platform as a service, specifically as it runs on Piston Cloud. So, Shawn, do you want to introduce your outfit?
Yeah, sure. So a little bit of background about Piston. So we were founded in around January 2011 by some of the original founders of OpenStack who were working at NASA and Rackspace. And for the first, I'd say, 3.5 years of the company, we were heavily focused just on OpenStack and being able to get people from bare metal servers, racking and stacking them, and being able to do this very quick install from zero to OpenStack in about 15 minutes from a USB drive, creating this distributed pool of resources of compute and storage and networking in a very short amount of time. So, we've taken that focus, and as I mentioned, and we'll talk about in a little bit, focusing on OpenStack, but now opening it up to more frameworks, as we realized from a lot of our customers that, OpenStack is one aspect, but people want to run things like Hadoop and Kubernetes and other frameworks on top of bare metal as well. So, as well as other things like PaaS and things on top. So, looking forward to discussing all this with you in this webinar, and let's go ahead, John, and move forward.
Yeah, just one more comment too is my understanding is that OpenStack traditionally has been kind of painful to get up and running if you just start from scratch. So my understanding of what you guys do is make that whole process much more reachable, much more simple to actually start from scratch and get a full working production ready OpenStack system in place. Is that correct?
Yeah, so that's a very good point. One of the things about OpenStack is if people that have developed with it and tried to build their own clouds, whether it's public or private, OpenStack is very large, and you have to make a lot of choices when you build these clouds. You have to pick, what hypervisor you're going to use, what networking solution you're going to use, whether it's Nova Network or some sort of Neutron implementation, and there's many third-party vendors that are making these SDNs. What storage backend you're going to use, whether it's Ceph or Gluster or others or some kind of iSCSI. And what we've done is taken a lot of the headache out of that and wanted something that you could install in an automated fashion, something that you could scale out and scale in your cloud very quickly. So if you want to add more resources, it's simply, you just add them and a lot of stuff happens behind the scenes. So that's correct. We want to take a lot of the headache out of that so that people don't have to manually install things, spend months trying to take all these different OpenStack pieces and make them work together, because there's thousands of options and trying to figure out which ones actually work together can be painful at times. So yeah, basically from zero to OpenStack or zero to other frameworks in a very short amount of time.
Which is exactly how it should be. An enterprise today that needs to deliver software, and that's all enterprises pretty much, they want to be focusing on what they're delivering, right? Whatever it is for their users or end users or customers. And they really shouldn't be spending time mucking around with the infrastructure or other things that are, really not their core competence. They're trying to deliver products, their own products, right?
Yeah, that's very true. We really want to, we really want to take that. We want to make sure that people can get their applications running quickly, because that's what it's all about, right? The faster people get their applications running, the faster they can get their products out the door, and they can save time, they can save money, and that's really what this is all about.
Exactly. Very good. So we've got quite a bit to go over today. Just briefly running through the agenda. We've already introduced the two companies, and I'll be spending a little bit of time introducing Platform as a Service a little bit more. And then we'll be looking at a number of other features. Much of them are related to high availability and scalability, which are two very important features for building and delivering any successful cloud apps these days. If it's not available, then it's going to cause a lot of problems, including financial problems. So we're going to look at those two features, I guess, on both Platform as a Service and Stackato, and also on OpenStack with Piston, and some of the interaction between the two. And if we do have time, we'll talk a little bit about orchestrating both of these layers over REST API. So we've got a fair amount to talk about here. So Shawn, why don't you kick it off, because you're at the infrastructure layer, so that's the basis of this whole thing.
Sure. So where I wanted to start was just to give you a little bit of a background on the architecture that we're talking about, so that you know what the infrastructure looks like, and then when John gets into talking about the Platform as a Service piece, you understand exactly where this PaaS is running. So if we look at this picture here, what we see are 5 what we call cloud nodes. These are the 5 servers on the bottom. On the top, we see what we call a boot node, and then there are 2 switches. One is a 1 gig management switch, and there's a 10 gig data switch. With these cloud nodes, this is what we have our hyperconverged architecture, where we actually have every server hosting compute and storage and networking, and basically all these servers are peers. And this allows us to really be able to run any service anywhere within the cloud. So all these are peers, and we don't have to really have separate compute nodes and then backups for the compute nodes and separate storage nodes. It's just that we can basically run anything anywhere, and it makes for adding more resources, because then if you want to add more resources, you just buy more of the same, stack them, rack them, get them into your cluster, and it's up and running. So in the beginning here,
all of the nodes are then pretty much homogeneous. Then is that what you're saying?
That's exactly right, and it saves time, it saves cost. You don't have to worry about this big thing about capacity planning. You just say, hey, we need more nodes. If we need 1 more, or if we need 10, or if we need 100, you just go out and buy more and add them into your cluster. Makes it very simple.
Very nice.
So when we install this, you want to make sure that the installation is easy. So basically what happens is you grab our software from our website, you install it on a USB key, plug that USB drive into the boot node, as you see with that dotted blue line. All the servers are racked, but they're not powered on. So if we go to the next slide, so you see that we power on the boot node. That's represented by that little blue lightning bolt there. We power on the boot node, and then that software that's on that USB key will get installed onto a hard drive on the boot node. The boot node will reboot, and then when the boot node actually comes back up, if we go to the next slide, we will see that over this management network, we will detect that how many servers are out there, how many of these cloud nodes are out there over this management interface. What happens is we get a DHCP request from these cloud nodes over this management network. The boot node will detect that, will respond, will give it an IP address, and then via an IPMI command, we will power on all those servers. So if we go to the next slide.
Quick question quickly here before is, does there anything at all have to be done with these nodes before you do this, or they can just be fresh out of the box servers?
Yeah, so there are some things you have to do. So you have to make sure that the BIOS configuration is correct for all of these servers. So, for example, you have to make sure that you're going to PXE boot from the 10 gig NIC. You're going to get your IP addresses from DHCP because you don't have to actually statically configure an IP address. You have to make sure that virtualization is enabled, that the IPMI usernames and passwords are set up correctly. So it's things like that to make sure that we can actually detect these servers in an automated fashion.
That makes sense. So it's just some basic configuration. Okay, so
yep.
The next slide then.
So then, as I mentioned, we assign the IP, we power the servers on via an IPMI command, and then over time they'll power on, they'll boot up, and then once they're booted up, then we do this installation of our software into a RAM disk on all the servers via the 10 gig data network. So that'll be the next slide. To where the same thing kind of happens on this side. So once the servers are powered up, we're going to get a DHCP request from the 10 gig NIC. We'll provide an IP address. And then what happens here is our software will go off and detect all the hardware that's in these servers first. So we'll know how many hard drives are in there. We'll know what their capacities are. We'll know how much RAM is in there. We'll know what kind of NICs are in there. So we'll do a full resource assessment of what's going on in all these servers. So then when we create this distributed pool of resources, we understand exactly what resources are available. And again, things are stateless. So we install this software into a RAM disk. We don't install on the hard drives themselves, because basically what happens is there's no need to actually log into these hyperconverged servers, because there isn't really anything to see on those nodes. And what we found is most of the any kind of security intrusion happens a lot of times from people that are inside the organization. So being able to have an architecture that doesn't allow people to actually get on the physical nodes is a good thing, and it's something that you don't have to do here.
Right. So now if you're installing you're not installing anything on the hard drives of the nodes themselves, meaning all that storage is available for the user, for the application. Is that right?
Yeah, so all that storage is available. We do carve out a little bit for us when we're installing Ceph. So Ceph is the storage backend that we use. So there is a slight amount of space that we Piston reserve, but other than that, almost all of it is reserved for the end user to be able to run their workloads.
Very good. Okay.
Cool. So moving on then. So we see that the installation takes place. This is probably about a 10 to 15 minute process from when you actually put that USB drive into the boot node and then get your cluster ready to be run. So I mentioned we do the hardware detection. We create this distributed pool of resources where this pool is shared across the entire cluster. So we have Ceph as the backend storage where we make sure that your data is replicated 3 times across the cloud, guaranteed to be on 3 different servers. We have a few different options for the networking piece that you choose, whether it is that Nova network from the original OpenStack, or if you want to do Neutron with plugins from PlumGrid or NSX or even Open vSwitch. And then we use KVM as a hypervisor here. So we go to the next slide, then we're up and running, and we have our dashboard. So you can see that this is the Piston CloudOS dashboard that you get to. It'll show how many servers are running. We have servers shown here that are ready to be added into the cluster. You might have one that's unknown. Say somebody comes in and accidentally plugs their laptop into that switch. We'll still detect that there's some hardware out there, but we won't really do anything with that. And then as you see here, we'll talk about it in a second, but if you want to remove hosts, there's that remove host button on the right there where you can select hosts and remove them. Or if you want to add hosts, you can do that as well. Simply click on the host that you want to add, and then that gets added into the cluster. And all this happens behind the scenes, and I'll show you how that's done in a second.
Great. This is really cool. So I'd love to just jump up a few levels and just ask a very high-level question here then. Typically in your customers that are using this, they would have, tell me if this is correct, they'd have a couple of IT people responsible for watching this, for monitoring and managing this display, this console. Is that usually how it is? And the developers would be just focused on the apps?
Yeah, that's exactly right. So what we'd like to do is be able to have as few IT people have to manage these clouds as possible. And you know, there's a lot of work we put into making sure that the cluster is self-managing, self-healing. You know, you do have a dashboard that you can look at through here. There's also the Horizon OpenStack dashboard that is available as well, that you can look at and monitor things. We do have people that are also using third-party monitoring solutions. You might have people using Nagios or Ganglia or Xenos or others. So basically, you know, 1 or 2 people can monitor this entire cluster up to hundreds of nodes very easily.
Very nice. Okay,
and the focus there is on making. Yeah, and just one last thing. The focus there is on making sure that people spend time doing what they are experts in and not having to learn how to manage and operate the infrastructure.
That makes total sense. Okay, very good.
So what we have then is we have, once you're all said and done, this cluster comes up, it's ready. This is just a diagram of what we actually have running in this cluster. So on the bottom here, you'll look and you'll see that we have these hyper-converged servers that are running this Piston CloudOS. What that's made up of is the cloud boot, which is a layer above, which is that booting we did from automating that whole install process. We have Linux, which is a hardened Linux that we've created simply to run this Piston CloudOS. So we've taken out and stripped it down to just what we need to run the operating system, and it installs in a RAM disk on every physical server. We have
Shawn, what is that? You said it says there Iocane Linux or something, or what is that? What is that term? I haven't seen.
Yeah, so Iocane is our name that we've come up with. It's our marketing name. So what we've done is we've taken Linux and we've customized it and hardened it and made it more secure. So basically, taken out any extra things that you might or that you don't need to run this Piston Cloud operating system. So there's no reason to come in and there's no need to install a certain flavor of Linux prior to installing Piston CloudOS. Our version of Linux that we've created is installed with Piston CloudOS. So it's basically a hardened Linux version. So on top of that, we have the Piston Cloud Fabric, which is this distributed network of, distributed resources of storage and compute and networking. Above that, the distributed cloud manager. So we're actually managing this entire cloud to make sure that it stays up and running 24 hours a day, 7 days a week. And then we call this our distributed cloud services, which is like our high availability framework to make sure that we can actually detect when there are problems in the cluster, whether they're physical server problems or any of the infrastructure services that might be running on those nodes. We can detect them and make sure that we can heal and survive from any kind of issues. And when those issues happen, an IT admin at their leisure can go and fix those issues because the cloud will continue to run.
So as you're moving up this stack, or let's say as you're on the top of this stack, what is the view, let's say, of what the storage looks like? I assume it doesn't look like you've got, you know, dozens or hundreds of disks. Is it just sort of an amalgamation of, it just says, you know, 600 terabytes of storage or something? Is that kind of what you're looking at?
Yeah, that's exactly right. So when you're installing the cluster, you do have, we do have a config file that gives you options for how you want that storage to be allocated. So we do have, for example, ephemeral storage. So if you want some storage to be allocated to your virtual machines that only lives for the life of the VM, you can do that. If you want most of your storage to be persistent and backed by Ceph, meaning if your virtual machine goes away, you still have copies of your storage saved, you can do that as well. So you kind of have a choice of dividing between this, what we consider ephemeral, and then we have object and block storage, which is there, that's backed by Ceph.
Great, very good.
So
Yeah,
I don't have more on this. I think if you click the slides through, what we'll see are those bubbles that'll come up from some of the things that I had described. Yeah, so if we, there you go, if we click the next two. So yeah, so then, yeah, if you can just go back one, John, right there. So, and then finally, I'm sorry, if you can go back one slide. Then finally, I just wanted to mention up on top there, we have these different platforms. So that's what I wanted to point out is with new Piston CloudOS 4.0, what we're seeing is we're starting out with Spark and Hadoop running on top, and OpenStack as well, and then we'll be moving into other things like Kubernetes and Mesos and Docker Swarm, and obviously the PaaS we can certainly install very quickly, Stackato running on top of Piston CloudOS. Thanks.
So the whole idea here is then at some point you'll be able to install these systems like Mesos or Kubernetes just as rapidly as today you are installing OpenStack and also Stackato, as we'll see shortly. Right?
That's correct.
Good. Very exciting stuff. Okay, so the next thing, the next slides discuss scaling out. So are you still on deck to go through those, Shawn?
Yeah, why don't we do that? We'll talk about the scale in, scale out process, and then a little bit about HA. I'm sorry, then we'll probably get into the PaaS discussion. Cool, so scaling out of the cloud, so this is basically adding more resources into your cluster, is very simple. It's just like the install process, where pretty much you rack and stack your server there, you plug it into your network, as you'll see on the next slide, and then we'll do the same automation here where we'll get that DHCP request from the server. Our software will power that server on. We will do the same, boot our CloudOS into the RAM disk on that server, and then behind the scenes, this server will become installed in the cluster, and then all those resources that come with it, the compute, the storage, the networking, will be in the cloud as well. So there isn't anything manual that has to be done here other than physically attaching your server or servers into your network. All this stuff happens behind the scenes, and then it becomes part of the cluster itself.
Okay, I think I want to just ask you about this then briefly. So by virtue of adding in new nodes, they will automatically be added to the overall cluster. Is there any manual intervention? I think you just said this, but I didn't get clear. From the dashboard or the administration console, it has to be done as well. That they have to manually add the servers, or they just show up when you plug them in?
Yeah, so they will show up. So in that dashboard, when I showed it before, there were two sections. One section had all the available hosts that were already in the cluster, and then there was a section below that that said ready to add. So what happens is when you plug these servers in, they will get powered on and then get in a state that they will be ready to be added. They won't actually be added to the cluster until the administrator actually clicks on that button and selects that button that says Add Hosts, and that's when they actually get added into the cluster.
Oh, that makes total sense. So at some point you could have quite a few systems just sitting there in the ready to add section here, and you can just add them at your will. That's very cool.
Yeah, exactly.
Okay.
Cool, so then if we go to the next slide, this is the scaling in piece. So scaling in is when you want to remove your resource or resources from the cluster, either for maintenance, maybe the server is having some problems. What we do here is a little bit different. So before we take any server out of the cluster, we have to make sure that any resources that are on there are going to get migrated off. So we have to make sure that any services running on there, so for example, you might have, if you're running OpenStack, you might have your RabbitMQ running on there, which is your queuing system in OpenStack. You have to take that service and put it on another server and keep it running. Any storage, for example, that's saved on that, or any data that's saved on that node needs to get moved off to another node as well. So we do all that behind the scenes, or any virtual machines for that matter. We have to live migrate them off. So looking at the next slide, I represent that by, you see here, we have those three green boxes or green cylinders on that bottom server. We move the data or the VMs off onto another server, and once they're off, then we're able to take that server out of the cluster. So then if you click the next slide, you'll basically see that this server is out, and then you can go do maintenance on it. You can go take that server or servers and use them somewhere else if you want them to be allocated for a different task. And then again, if you want to bring them back in, you simply add them back to the cluster and go through the scale out process where they get detected and added back in.
So how do things work? Like, for example, if one of these servers is running a service that's in the middle of responding to, let's say, a long-running request, do you have some sort of, I don't know, a timeout period after which you would just have to shut down the server? How does that work?
Yeah, so it really depends on what's running there. So we do have this distributed cloud services, which is our high availability framework. And a few things that we detect, we definitely keep track of what services are running in the cluster. So we know everything is running everywhere. And we use a Paxos-based algorithm, and we do this mastery election. So some of the services in the cluster will run on one node. Some of them might run everywhere. And we keep track of that. And should a service fail, should a service not be responding, maybe there's a network issue, these are things that we do detect. We will take that service if we need to and spin it up somewhere else very rapidly. If we find that there is some hardware issue or some other issue that's causing corruption or could cause corruption, we can actually fence off that server or servers from the rest of the cluster and even power them down if we have to. So yeah, so we do have a lot of stuff built into the product to make sure that we can make sure the cluster keeps running even if there are events, either hardware events or problems with the underlying services that are running.
And these are exactly the complexities that the end user really should not be dealing with if they're just trying to get their apps out the door. So it's a very good illustration.
Cool.
All right, so very good. Well, that's a great background. So what I'd like to do now is segue a bit and move up the stack and talk about using platform as a service on your stack. And that's what we'll be showing in a few minutes towards the end of this webinar. And before doing that, I'll just give a brief introduction on what we're talking about when we talk about PaaS and Stackato. As I mentioned earlier, Stackato is a Cloud Foundry-based PaaS, very enterprise hardened, and it allows developers to build and deploy and deliver applications using, as it says here, any language, any stack, running on any cloud. So it runs very well on OpenStack and on Piston Cloud. We also have designed it to run on other clouds as well, CloudStack and AWS clouds and VMware. And what this does allow you to do is very easily migrate your applications to OpenStack, for example. And it also supports pretty much any enterprise language out there, so Java and Ruby and Scala, etc., Clojure, etc., is supported by Stackato. You can provision your applications without having to worry about installing and configuring and patching the components that make up the frameworks and the languages. So PaaS is actually getting a lot of traction these days. I like to compare it to how source code management was several years ago, where people had started to hear about it, but still very few organizations had really started using it across their company. And yet the value of it is very high. And PaaS is kind of in that same boat. You know, everybody now is finally heard of PaaS, and it doesn't really need to be, the acronym doesn't need to be expanded as much at conferences anymore. But still, a lot of organizations are still just getting on board using it. There's some great benefits. It really does improve your time to market. Your development teams are much more agile by using it. And like Shawn was talking about, some of the features that he provides, that Piston provides, a lot of the plumbing and the underlying details get abstracted away from the developers, so the development teams can just focus on providing software, pure available software, without having to get into the weeds and get into the plumbing. So I like to have a quick look and see what exactly is in this thing. It gives a pretty good viewpoint here. I mentioned earlier, so in the middle box there, you can see the Stackato PaaS itself. It contains the languages and runtimes and frameworks and containers, things you need, like Java with Spring, Node.js, the Bottle framework with Python. All of these various runtimes and containers are just bundled with it, so no extra work to deal with that. In addition, Apache and Tomcat and Nginx and a number of other containers are also included with it right out of the box. We also provide a number of data services, like RabbitMQ also runs on Stackato as well, if you can take advantage of that. And data services like MySQL and MongoDB and Redis, etc., are also included. I should mention logging is an important feature of this. Logging cloud applications can be kind of agonizing. A lot of work involved making sure agents are installed and disks don't fill up and the logs are collected across your, let's say dozens or thousands of services that are starting up and stopping at their own speed, their own time frame. It can be difficult to reliably capture your logs, and we provide mechanisms to make that a lot easier. So the logs for any number of your application and service instances are captured, can be aggregated and centralized, or sent off to an external logging provider like Splunk or Loggly or something. Let's see. I think that's enough to cover on this slide. I'll show you shortly how it all works from the user's point of view, as far as the icon on the left showing about pushing your apps to the PaaS or to the cloud. You can use a command line interface or use your IDE, and we expose a REST API as well. So looking a little bit more into the architecture itself, this green box, this green rectangular box here represents the PaaS itself. So everything inside that green box is in the PaaS. And all of these components are delivered as either VMs or containers inside the PaaS. And the ones I want to draw your attention to, the important ones, are on the left there. It says the cloud controller. This is kind of the orchestrator of the whole thing. It exposes an API, a REST API, allowing the PaaS to be managed and accessed and queried and controlled and monitored, etc. And it takes care of authentication and some other parts. We have, as you can see, there's a load balancer on the top. That's typically provided by the customer, but it would load balance between routers, and the routers themselves route the traffic to the specific application instances that are running in the PaaS. So you might have hundreds or thousands of app instances running inside the PaaS, each sharing the load. the router takes care of routing the traffic to each one of those app instances. And then you could have multiple applications, each with a different URI running inside the PaaS. The router takes care of routing between them. So then it gets me to the topic of what we call DEAs, or droplet execution agents. These are virtual machines or systems that are responsible for running the containers that contain the applications. We use Docker containers. We're actually the first commercial product to have shipped with Docker, other than .cloud itself, who invented Docker. So we've been using Docker for quite a while now, well over a year, inside of Stackato. The DEAs are the VMs that are responsible for running the Docker containers. And you can have any number of these DEAs, and as you saw earlier with Piston, each one of those nodes could be allocated as a DEA. So you can have any number of those, and then each one of those can run large numbers of Docker containers. Other things to mention is the data services, which I mentioned earlier. So you could have file systems and databases and messaging services. That's all part of this. LogYard is to assist with aggregating these logs we were talking about. It's easy to wire in external monitoring tools into the PaaS, so you can have your applications monitored by Nagios or New Relic. And we also have our own internal health manager, which keeps tabs on everything, makes sure the containers and the application instances are running correctly and responding to requests, making sure that we're not running out of resources, and to take action in case we are. So that's kind of a high-level overview. Go ahead, Shawn.
Hey, John. Yeah, just a quick question. So I'm looking at the green box here, and do end users have to worry about what's going on inside the green box, or do they just once everything is up and running, they really only have to take care of the third-party and external tools?
Yeah, that's a great question. Yeah, it's just as you say. The end user has access to the API or to a web console to manage all this stuff. They don't really care about the details of it, so it doesn't matter how many DEAs are running under the cover, and it doesn't matter the structure or the routing or anything. They just care about their viewpoint, which is, can I deploy my applications to this, and can I tell it to scale up to a certain number of instances? It's very abstract in that level. That's exactly the point.
Excellent. Very cool.
Okay, so that's the background of PaaS, and I'm gonna, if given time a little bit later, I'll run through the actual use of it. But why don't I hand it back to you, Shawn, and you can talk a little bit about the high availability here.
Sure, thanks, John. So we have high availability in a couple of ways here. One is, of course, at the infrastructure layer. I'll talk about that, and then I think John could talk about how HA works at the PaaS layer. So I mentioned earlier what we do is that we use this kind of master election process to elect where these infrastructure services are going to run. These are the things that keep the cloud up and running, everything kind of up to the virtual machine level that you want to talk about, the OpenStack side of things. So we can detect hardware failures. We can detect when these services are stop running or are having issues. So for example, if you look at on the left side here, we have 3 servers that are running, and there is MySQL that's running. And this would be a MySQL instance that's running at the infrastructure level, so stuff that Piston is keeping track of data. This isn't something that's running in a virtual machine. So that server that's running the MySQL crashes, something happens, we don't have access to it anymore. Whether it's the motherboard crashed or maybe the network is down, we just can't get to that server. So we detect that, we quickly spin up that MySQL instance on another server, and the cloud just keeps on running. So, this is this HA framework, and then on top of that, we can even fence off that server to make sure that we know that, hey, that server has problems, that server is going to be, from right now on, out of the cluster until the admin can come in, take it out, do whatever maintenance needs to happen, and bring that back in. So again, it's making sure that this cluster is up and running. Any data that was on that server, so for example, I said that we use Ceph as our persistent storage backend that replicates 3 copies of your data on 3 different servers. So the copy on this server that's gone away, Seth can detect this. It'll spin up a 3rd copy somewhere else within the cloud. So assuming we have more than 3 servers, maybe we have 5 or 10 or hundreds, that copy will show up on one of the other servers in the cloud. So again, there is HA at the infrastructure level, making sure that the servers and services that they are running stay up and running at all times.
So this looks slightly similar to the scale-in process. Is there any relationship between the two? Is it similar? Is it completely different?
Well, it's similar, but it is different in the sense that in the scale-in process, we go through a series of steps to make sure that prior to removing a server out of the cluster, we very nicely migrate all the data off. So we'll migrate the VM to another server. We'll take any Ceph data and migrate that to another server and store it somewhere else. Any services that we're running on that server, we'll move them as well, and then we can power down and take that server out. In this one, it's more of a, hey, my server just crashed. How do I get the data off of it? So again, that server crashes. We have replicas of the data that are already on other servers, so we can just make a copy from another server and make the 3rd copy. Or if your VM is running on it and if it's a persistent VM that is created from a volume that's backed by Ceph, again, you'll still have your VM there. And I'm sure, as you'll talk about, we do depend on the above PaaS to make sure that the VMs are spun up again if they need to. We don't automatically spin the VMs up. The VMs will be there to be spun up, but we don't take care of automatically spinning them back up.
Right, and that makes sense that it would be done at the higher layer for sure.
Yeah.
Very good. Yeah, and that's what you're talking about. That's very complex stuff, and it's a relief to know that the end user does not have to worry about the underlying mechanics of all that. So what I'd like to do now is the next thing on track here. Is just to show the use of the PaaS running, use of Stackato running on OpenStack. And I'm just going to run through briefly what it looks like because I think it's important to get an idea about here. Just running back to this slide here. As I mentioned earlier, we expose an API, a REST API for managing this thing, and then a number of clients which take advantage of the REST API. So there's a command line client, there's a web-based client, and you can have plugins for IDEs and plugins for Jenkins, etc., that can manage the PaaS itself. And so what I'm looking at here is the web interface for accessing and managing the PaaS, managing Stackato. There's a number of things I can do here, and I'm just going to show a couple of very brief operations. So the first thing I'll mention is you can deploy an application automatically. We have this App Store concept, which is a list of applications available that you can deploy at the click of a button. And it shows a number of different languages that are available. There's Java and Ruby and Python and Perl and Clojure and Node.js, etc., JavaScript. So any of these can be deployed at the click of a button. And in order to deploy an application, you can just go and click Deploy Application. It asks you for a name for the app, or it automatically generates one. It asks for a space to place the app in. I can get into that later. And a placement zone as well. You can specify that. And then I click Deploy. What this is, in this case, doing is it's grabbing the bits for the app from GitHub and staging the application on a container, a Docker container that will then be used as the template for deploying multiple instances of this application. And what you can see here is the logs are being displayed in the console in this web interface. And these same logs can also be automatically directed elsewhere to Loggly or Splunk or wherever you want. And so this particular screen is showing the status of this application. You can see a summary of it when it went out. There's a timeline where you can add forum discussions on it if your development teams or other teams want to communicate. It shows the versions of the app that have been deployed. This one is still deploying. What I'll do is I'm going to visit a different app here that I've deployed earlier. And see 3 versions of this application, or this app was deployed 3 times basically. And so Stackato is tracking the 3 versions of this application, version 1, 2, and 3. And I can roll back and roll forward these versions just by clicking a button. This is a very rapid and available process. So there's no downtime as far as the end users of these applications are concerned. If I roll back to a previous version, it handles it very gracefully. And so this is actually a Python app, and it's based on the bottle currency framework. And if I click View App, it's going to show me the actual running app running inside a browser. So this is actually a 3-tier application. It has a Redis data service underneath, and I can click various countries, and it'll show me the currency rates between them. And this is presumably calling some bank web service to figure this out, because it is. So it's a very simple app, but it is a 3-tier application that can be deployed with the click of a button. And so back to Stackato here. As I mentioned earlier, I can roll back to a previous version of this application, and Stackato will take care of gracefully, well, starting up the new instance of the application and then gracefully shutting down the previous application. And you'll notice here the title says Friday Currency Converter. Oh yeah, and now it's rolled back and it just says Currency Converter. So that was the update I made to it earlier. So you can see it very easily handles versioning of applications. A number of other things you can do here is inspect the environment for the application, look at the files that are associated or that have been uploaded with this application. And this is what I really wanted to get into. And this will tie into the discussion we had on scaling with OpenStack. This is really important. With Stackato, you can enable auto-scaling. And what this will do is allow Stackato to monitor the performance of the application, and then, if required, spin up new instances of the app. And with this slider here, I could say, well, I want to have no more than 10 instances, and let's say no fewer than 4 instances running. So just by having moved that slider, you'll see now that Stackato automatically spawned up 3 additional instances of this application, and they're running across the network. And then using the first slider here with the threshold, I can say that, you know, if the CPU usage drops below, let's say, 12%, then it'll reduce the number of, it'll reduce the number of instances running. And if it goes above 80% here, it will add a new instance. So that's how you can use that. All of this functionality is available via our REST API. But it actually brings in a very important concept, which will now tie back into the discussion earlier. And that's the discussion of scaling. So there's kind of 3 layers of scaling we're talking about here. What you just saw with the scaling of the app instances themselves is auto-scaling of the containers. So no additional resources have been allocated. Instead, presumably there are resources available. Stackato will simply spin up another Docker container to run the application and then route traffic to it, you know, load balance the traffic across all the instances. So that's one layer. But there's also very commonly the situation where there's not enough resources to run the application, let's say not enough memory or not enough disk space, etc. And Stackato can automatically call down to the infrastructure layer, like down to OpenStack, Piston system, to request a new VM is spun up. And so that's the Stackato calling down to the OpenStack layer to ask for new resources. And that can happen completely automatically too, or under the control of the REST API or the other. And then presumably the third auto-scaling layer is what Shawn talked about earlier, where add new hardware nodes and they get automatically or close to automatically added to the cluster. So how's that look so far, Shawn? Is that give any questions about what we have so far?
Yeah, this is great. I think the one question that I had as well is, I talked a little bit about the HA side and if we happen to lose a server or an infrastructure service. What happens in the Stackato case if something like that goes down?
That's a very good question. And that leads me into talking a little bit about placement and availability zones. So I'll just briefly define what they mean. So with placement zones, you can group your VMs, or group the systems that are running the DEAs, running the applications together, and make sure that you restrict applications to be deployed on those inside one of these placement zones. So typically that would be used for, team isolations, for example. The QA team might have their own. You would only want QA to deploy on a limited subset of systems, or maybe there's security policies or performance considerations to keep in mind that you don't want certain things running on your production servers, or you do want your production applications running in certain places. So that's the concept of placement zones. But more related to your question are availability zones. And when a node is added to Stackato, you can tag it with an availability zone. And so if you have, and these correspond to the EC2 zones and presumably the availability zones on. For example, if you've got two separate racks, so rack 1 and rack 2, you could tag every node on one server as rack 1, and every one in the other rack is rack 2. And Stackato will make sure that if you have multiple instances of your application running, there is one instance running in each one of these availability zones. So it guarantees if one zone goes down, your application will continue to run. So it's an important feature of Stackato, but it's very abstract in the sense that you basically just tag your nodes with one of these availability zones, and then Stackato does all the underlying work to make sure it actually stays available. So Shawn, excuse me. I assume that you have the similar concept of availability zones with OpenStack. Is that right?
Yeah, you're correct. There's a concept of availability zones in OpenStack. You can select and create different regions. So yeah, we have that exact concept as well. And then
Perfect.
those
so
are pretty
easy
to set up.
Yeah, and the availability zones that we define here would correspond one-to-one to your regions, almost certainly. So then it's up to the deployers to decide how they want to partition their various zones.
That's correct.
So that kind of covers most of the content that we wanted to cover today. I would like to mention that if you are looking at Cloud Foundry, it's definitely worth looking at. If you're looking at Cloud Foundry, I strongly recommend you look at Stackato as a way to get started with it. Installing Stackato takes all of 5 minutes. You just basically boot the VM, and it's similarly just as easy to do so on Piston's stack. So just to cover the last part here, we are going to be at OpenStack Summit in 2 or 3 weeks. Shawn, will you be there as well?
Yeah, so we will definitely be there. I'll be there all week from Sunday through Thursday. So yeah, we'll definitely be at the summit. And also, Piston's going to be hosting another webinar on May 12th on Piston CloudOS and some of the frameworks that we're going to be running on top as well.
Oh, very good. Okay, well, I'll definitely see you up in Vancouver for OpenStack. That'll be great. Have any questions come in, by the way? I don't have view of the question.
Yeah, so I do have a question. The first one is, how do we compare ourselves to similar offerings from Mirantis Fuel or Red Hat Foreman? And so I think these things specifically asking about how we do the install, and because the Foreman and Fuel have to do the install. So our Cloud Boot install, so we actually designed that very early on when we first developed our product back in 2011. So we started out with the Cloud Boot because there wasn't really anything available yet that actually took care of the install. So as a company, we were actually the first one to do this automated install, put your software on a USB in a boot node, and then do all the auto detection. The thing that you have to do with our install is basically we come up with a config file, and then once that config file is filled out, which covers things like network ranges and how you want your storage to be configured, once that's done, then the rest of it is really just the automated install of the software, or I'm sorry, the automated booting into RAM of the cloud operating system, and then you're up and running. Whereas some of these other ones, like Red Hat Foreman, for example, there are other packages and things that you have to install prior. It just isn't a simple one click of a button. So Fuel is more like ours in the sense that it does the auto detection and powering onto the servers. It's just that ours was, because we had done it first, we didn't bother to use anything like Puppet scripts and things like that to get it done. This was just full custom code that we built in-house.
Very good. Okay, are there other questions?
I don't see any here on mine. That was the only question I got, but to all the attendees, feel free to submit some more questions in the chat window if you'd like, and we'd certainly be happy to answer those for you.
Yeah, if we don't get to them today, we probably won't because we're actually out of time, but we'll we can answer any questions that come in by email. So sure. I think that pretty much covers it. Shawn, I want to thank you for taking the time to join me. That was a very interesting discussion, and I will look forward to seeing you in Vancouver in a month or so.
Yeah, thank you very much too, John. It was fun, and thanks to everybody who attended.
Exactly. Thanks for the attendees, and we'll catch you at the next one. By the way, this will be recorded, I believe, and you'll probably be notified as to how you can get access. Thanks.